Antarctica, the world's largest desert, home to the dry valleys and the remarkable McMurdo dry valleys. And also it has a secret, a giant lake of liquid water that has been hidden beneath the ice sheet for millions of years. The discovery of Lake Vostok was accidental. In 1996, scientists were using ice-penetrating radar to map the thickness of the ice sheet when they noticed something unexpected. There was a flat reflector under the ice, which could only be the signature of liquid water. They named this mysterious Lake Vostok after the Russian research station that sits on the ice above it. But how do you find out if there's a lake under 4 kilometers of ice? Scientists turned to satellite altimetry to see if they could spot a smooth surface bulge in the ice sheet above the lake. Sure enough, they found one. By combining radar, satellite and surface observations, scientists had a pretty good case for a large subglacial lake sealed beneath the ice sheet. In the early 2000s, seismic surveys confirmed that there was definitely a water body there, because the pressure at the bottom of such a thick ice sheet is immense. It lowers the melting point of ice, allowing liquid water to persist. And while the water at the bottom of Lake Vostok is probably not tropical, it is warm enough to support liquid water. Geothermal heat from Earth's core warms the lake base, but how does that heat get to the water? The ice sheet acts like a blanket or an insulator, keeping the water from freezing. Even though the air temperature at the surface can get to -89 degrees Celsius, the water temperature at the bottom of Lake Vostok is around the freezing mark. Like any lake, Lake Vostok has a water body, but it also has a submerged shoreline where the water meets the land. In some places, bedrock ridges under the ice sheet reach above the water table, creating islands and exposed areas of rock called nutoks. Here, lake water freezes to the base of the overlying ice, forming a layer of ice called accretion ice. This ice grows thicker towards the center of the lake, and the friction from the surrounding ice creates enough heat to keep the bottom layer of the accretion ice from freezing. So Lake Vostok is constantly refreezing itself from the bottom up. And just how much ice is there above Lake Vostok? About 4 kilometers, give or take, and that's only the average thickness. Some places are much thicker. But even at that depth, there's still enough water to fill Lake Vostok to a depth of 600 meters. But Lake Vostok isn't the only body of water down there. It's connected to a whole network of subglacial lakes and even subglacial rivers, all linked together by basal hydrology. For example, the SA channel that carries water from Lake Vostok to the nearby Amory ice shelf, and another that connects Lake Vostok to the ocean through a network of subglacial rivers. So what's the chemistry and physics of Lake Vostok? Well, it's cold, about 3 degrees Celsius. The pressure is really high, around 250 times atmospheric pressure. The water has dissolved gases in it, like oxygen, nitrogen, and carbon dioxide. And it might be stratified with layers of water of different densities and temperatures. Could there even be life there? Microbes could use the chemical energy known as chemosynthesis in the absence of light. In other words, the microbes could survive by eating rocks. We know that microbes have been found in accretion ice samples taken from Lake Vostok, but whether or not they actually live in the lake is debatable. Some scientists think they may have contaminated the samples from the surface. Scientists have drilled many boreholes into the ice at Vostok Station, but they haven't drilled into the lake itself. And that's because they don't want to contaminate it. So instead, they've developed very clean drilling protocols to prevent any contamination from the surface. Then they analyze the chemistry of the ice they drill through to learn about the lake. For example, they found that the accretion ice is enriched with iron, manganese, zinc, copper, nickel, and cobalt. And this chemistry suggests that the lake water is oxidizing, reducing, stratified and anoxic, meaning that there's no oxygen. Lake Vostok is just one of several subglacial lakes in Antarctica. All of these lakes together make up the biggest known system of subglacial lakes on Earth, and they exist because the ice sheet above them insulates the water from the frigid polar air at the surface. Parts of the East Antarctic ice sheet also contain fast ice streams that carry ice and snow downhill toward the coast and the Southern Ocean, and those streams have their own unique geology and ecology because Antarctica contains so many subglacial lakes and subglacial rivers. It's an ideal place to look for analogues to Europa and Enceladus, two moons of Jupiter and Saturn that are covered in ice, but may have liquid water oceans beneath their icy shells. And because the ice sheet above Lake Vostok is so thick, it preserves ancient information about past climates. In other words, Lake Vostok is more than just a lake. It's a window into the past and a possible window to the future. If you liked learning about Lake Vostok, give this video a like. And check out our other videos about the amazing discoveries being made in Antarctica right now. Thanks for watching.